Hello friends, today's question. A ring of mass 0.3 kg and radius 0.1 meter and a solid cylinder of mass 0.4 kg and of same radius are given the same kinetic energy and released simultaneously on a flat horizontal surface such that they begin to roll as soon as released towards a wall which is at the same distance from the ring and the cylinder. The rolling friction in both cases is negligible. The cylinder will reach the wall first. So this basically is a true or false question. So we have to see whether this statement is true or it is false. So it is given that a cylinder and a ring are moving towards a wall. So let us suppose this is a wall and it's moving with the angular velocity omega, and the radius is given, let us suppose, is r, and the center of mass is moving with the velocity v. Okay, so this is the case for both, whether it is a ring or it's a mass. So we can say that in case of v is the velocity for the center of mass. You can say v is the velocity of center of mass, and it is rolling with the angular velocity of omega, angular velocity. Therefore, we can say that v is equal to omega r. We are going to use this relationship for both the cylinder as well as ring. So let us first of all write it for the ring, for the cylinder rather. We can say for cylinder, its velocity, let us suppose, is represented vc, and omega c is its angular velocity, and the radius is r, where c is our cylinder. Similarly, we can write it for ring also. You can say for ring, omega r is equal to omega c. Radius is same in both the cases. Here this small r is a representation of ring. So let us first of all find out what will be the kinetic energy of the ring. We can say kinetic energy for the ring will be consisting of two parts. First will be the kinetic energy because of the rotation plus kinetic energy because of the translation motion. So let us find out first of all kinetic energy of the rotation. So kinetic energy of rotation will be equal to half mi of the ring multiplied by its angular velocity, rather square of, and similarly we can write that kinetic energy for the translation will be equal to half omega r, and that will be VR square. So let us substitute. We already know that VR is equal to omega r. Here it should be r. VR is equal to omega r. So let us substitute here. So we get this as half omega r, and this will be equal to my mistake, this is mass. Okay. So here mr is the mass of the ring. We can say this will equal to half omega r, mr, and Vr is given as omega r whole square. So this becomes half mr omega r square and r square. So let us substitute it in the equation. So we get kinetic energy for the ring will be equal to half I ring omega square plus half mr omega r square and r square. And we also know that the moment of inertia of the ring is given by the equation. Let me write it here. I of the ring is equal to mr multiplied by r square. So we are going to substitute this value. We get this as kinetic energy for the ring will be equal to half mr square, mr, let me write it again. Kinetic energy of the ring is equal to half mass of the ring, radius of the ring, multiplied by omega r square plus half mass of the ring, omega r square and r square. If you add them, we get kinetic energy of the ring will be equal to mass of the ring, omega r square and r square. So let this be equation number 1. Similarly, we can write for the cylinder. Similarly, for cylinder, you can say the kinetic energy of the cylinder will be equal to kinetic energy because of the rotation plus kinetic energy because of the translated motion we get this as half moment of inertia of the cylinder and omega c square plus half mass of the cylinder multiplied by velocity of the cylinder, center of mass velocity, where mc is the mass of the cylinder. mc is the mass of cylinder. And we already know that our Vc is equal to omega c multiplied by r, and its moment of inertia Ic is given as mc r square divided by 2. Okay, but moment of inertia for the cylinder is given as mc r square by 2, and we have our Vc is equal to omega c multiplied by r. We substitute these two values and get the kinetic energy of the cylinder will be equal to half mc r square divided by 2 multiplied by omega c square plus half mc, and here you get omega c square and r square. Solving this, we get kinetic energy of the cylinder will be equal to, this will be 3 by 4 mass of the cylinder omega c square and r square. So this is equation number 2. In the question, it is given that the both have the same kinetic energy. You can see, but kinetic energy of the ring is equal to kinetic energy of the cylinder, and this is given. So we are going to use equation number 1 and 2. Using equation 1 and 2, we get mass of the ring omega r square, and r square is equal to 3 by 4 mass of the cylinder omega c square and r square. R and r cancels out. You can say mass of the ring is given as 0.3, omega r square is equal to 3 by 4, mass of the cylinder is given as 0.4 multiplied by omega c square. Now it is only a calculation. Let's say that omega r square divided by omega c square will be equal to 3 by 4 multiplied by 0.4 and 0.3, which will be coming equal to 1. So this implies that omega r square is equal to omega c square, or we can say omega r is equal to omega c. And we also know that omega r can be written as r multiplied by Vr, which will be equal to r multiplied by Vc. Here also r and r cancels out, therefore get Vr is equal to Vc. So therefore velocity of the cylinder is equal to velocity of the ring. Here we can say velocity of ring is equal to velocity of cylinder. So which basically mean both will reach the wall with in same time. Both will reach the wall together. In the question, it was given that the cylinder will reach the wall first. So this statement is false. Okay. So we can write it here that the given statement which is the cylinder will reach the wall first is false. So this completes the question. Thank you.